In this video, we're going to study about continuity test. Now we know what a continuous function is, a function which can be drawn without lifting our pen, or we can say if there is no abrupt change in the values. So this is called a continuous function. Now we have to pass through 3 tests if we want to check for continuity of function. If it passed through 3 tests, then it's a continuous function. If it doesn't, then it means it's a discontinuous function. The first condition is f of a is defined. For this, I will take a function f of x. So it means you can take any arbitrary point. I will take x equal to a over here. It means corresponding to a value, we will have a y value. Now you can see in this function, corresponding to a, we're getting a value corresponding y value. That is f of a. This means f of a is defined. Function is defined at x equal to a. The second one being is limit when x approaches a, f of x exists. That means the limit should exist for this function. It means if we take left hand limit and right hand limit, if they are equal, so we say the limit for this function exists. The second point is limit x approach a from negative side for function fx should be equal to limit x approached a from positive side f of x. If left hand limit and right hand limit are equal, it means the limit exists for this function. You can check even if we approach from left side or right side, the function does have a y value from left side and right hand side that are equal. Since the limit that of a left hand side and right hand side are equal, we say that limit exists. The third one is if the value, the output that you got from function and that of a limit, if they are equal, we say that a function is being continuous. Since we know that for this function, the limit value, that is limit x approach to a for function fx, this will have some value, will be equal to limit, it is a functional value, that is f of x or f of a. If the functional value or limit value are equal, we call it as a continuous function. Let's check continuity for some of the graphs. Here in the picture, we are given a graph and we have to check if the function is continuous or not. First, we will check if f of a is defined. We can see that when x is equal to a, we're not getting any corresponding y value. Here it is a hole. Since there is no corresponding y value, we say that f of a is not defined. If it is not passing through first condition, that means this function is not continuous. Even in the graph, you can see that there is a hole, so this function is not a continuous. I will take second graph. The first condition is we will have to check if f of a is defined. That means corresponding to the x equal to a. Is there any y value? Yes, in the graph we can see that when x equal to a, we are getting a y value, that is this. f of a. F of a is defined, so first condition is passed. Second one is, does the limit exist for this function? We will approach this function from left side and then from right side. From left side, we can see that the left hand side limit is this. The left hand side limit is this. Okay, and from right side the limit is this. Are the two limits equal? I mean, from left hand side, is it equal to right hand side? No, of course it is not. The output that we are getting is different. So we say that limit x approach to a from negative side for function fx is not equal to limit x approach to a from positive side f of x. Since the second condition is not met, that means limit does not exist, so it is not a continuous function. Let's take the third graph. We have to check if this is a continuous function or not. First, we will take first condition, that is if f of a is defined. That means corresponding to x equal to a, is there any y value? We can see that yes, corresponding to x equal to a, we do have a y value. That is this. F of a is defined. First condition is met. The second one is that we have to check the limit. Is left hand limit equal to right hand limit? Let's check that. If we approach this from left hand side to this function, the corresponding y value that we're getting is this. And if we approach it from right hand side, the corresponding value that we're getting is this. Since left hand side limit and right hand side limit are equal, limit x approaching to a from negative side for function fx is equal to limit x approaching to a from positive side for function fx. So we say that limit exists. That means limit for this function exists. Limit for this function exists when we are approaching to a. Limit exists, the second condition is satisfied. Now let's check the third condition. Is the value for the function, that is value of this and value of this, are they equal? Of course they are not. For the function we are getting this value. For the limit we are getting this value. Of course they are not equal. That is, the value that we get for function is not equal to what we got from limit. Since third condition is not met, we call this a discontinuous function. Let's check one more graph. Is this function a continuous function or not? We can see that from graph it is not continuous, but let's check it algebraically. We know that first condition we have to check if f of a is defined. Is it defined? We can see that corresponding to the x equal to a, we are not getting any value for y value. Since we are not getting any y value, that means f of a is not defined. So it is failing for the first condition, so this is not a continuous function, this is a discontinuous. Now let's take some example and check the discontinuity for functions. Determine whether the function fx equal to 2x plus 1 whole divided by 2x squared minus x minus 1. For example, if we want to check its continuity at x equal to 1, first condition is f of 1 defined, or we can say f of a defined? Is function defined when x equal to 1? We will have to put x as 1. So it will be 2 into 1 plus 1 divided by 2, 1 square minus 1 minus 1. Simplifying it, it will be 3 divided by 2 minus 1 minus 1. That is 3 divided by 0. So we know anything divided by 0, it is not defined. So function is not getting any value corresponding to 1. So f of a is not defined. Since it does not meet the first condition, we say function is discontinuous. Let's move ahead. You can check continuity even, for example, x equal to 2, x equal to 3. Here in the graph you can see this. Corresponding to the x equal to 1, we're not getting any y value. Since we are not getting any y value, that means function is not defined at x equal to 1. So this is not a continuous function. You can see that in the graph. The second example is that of a piecewise function. We will have to check if the function is defined for x equal to 0. If the function is defined for x equal to 0, that means we know that at when x is equal to 0, the function that we have is x plus 2. We will put x as 0 plus 2. Yes, that means we're getting 2. Function is defined at x equal to 0. F of a is defined. Now, the second condition is left hand limit equal to right hand limit? If we want to find the limit when x is approaching to 0 from negative side for function fx, limit x approaching to 0 from negative side, we will take the function that is lesser than 0. That is the first part, x plus 2. Now substituting x as 0, the value that we're getting is 2. So left hand limit is equal to 2. Now we will check for right hand limit. Limit x is approaching to 0 from positive side, f of x, limit x approaching to 0 from positive side. In this case, we will take the part that is less than 0. In the second example, we have to check if the piecewise function is continuous or not. If I check the first part, x plus 2, we know this is in the form of linear. This is a linear function. And linear function is always continuous in its domain. And the second part being constant function, it is also continuous at every point. Third part is x squared plus 2. We know this is a polynomial function. And a polynomial 2, linear in the form of line. Constant is like this. And polynomial is like this. So each of the piece, they are continuous in their domain. but we need to check continuity of these pieces at x equal to 0 and x equal to 1. If I talk about them individually, they are continuous, but we have to check if the pieces they are continuous or not. Pieces as a whole function. First, we will check if the function is defined for, first we will check for this, for f of 0. We know that for x equal to 0, we will take this part, x plus 2. And we will put x as 0. We're getting f of 0 as 2. That means function is defined at x equal to 0. We are getting some output. When x equal to 0, we are getting some y value. First condition is passed. The second condition is, does limit exist for x when x is approaching to 0 from left hand side and x is approaching to 0 from positive side? Or we can say, does limit exist when x is approaching to 0? If we want to check the limit, we will have to find the limit from left hand side and that of right hand side. Limit x approaching to 0 from negative side. From negative side, we're taking the values that are lesser than 0. So for this, we will take function x plus 2. And if we put values of x equal to 0, we are getting limit as 2. That means limit for x approaching to 0 for function fx, we are getting 2. Now we will have to check limit x approaching to 0 from positive side. From positive side, we will take the piece that is greater than 0. We know the second piece is greater than 0. That is 2. We know the constant function. It doesn't matter where we want to find limit. Doesn't matter. Okay, suppose this is a constant function. You want to find limit here, 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 at anywhere. Its limit is always equal to that of a constant number. So its limit will be equal to 2. So we can see that left hand limit and right hand limit, they are equal. So we can say that limit x approaching to 0 for this function is equal to 2. Okay, that means the second condition is satisfied. The third one is, if the value that you got from limit and the value that you got from function, if they are equal, yes, here we can see that the value that we are getting is 2 and the functional value we are getting is 2. Since limit x approaching to 0, f of x is equal to, or f of 0 is equal to f of x at x equal to 0. Since they are equal, we say that at x equal to 0, the function is being continuous. That means the first part, that is this linear part, and this constant part, they could be anything like, for example, it's a linear part and constant part. They're joined together without any discontinuity. At x equal to 0, they're joined together, they're merged together. So at this point, the function is being continuous. Now we will have to check at x equals 0, it is continuous. We will have to check for x equal to 1. First, we will see if function is defined for x equal to 1. Is function defined for x equal to 1? Of course, we can see that for x equal to 1, we will have to take this part, that is second piece, whose value is equal to 2. Now we will check limit x approaching to 1 from negative side. From negative side, we're going to take the piece, second piece, that is constant number 2. So we know that you want to find limit for a constant number, doesn't matter where you want to find, it's always equal to that of a constant number. So its limit will be 2. Left hand limit will be now we have to check for limit x approaching to 1 from positive side. For this we will take piece that is greater than 1. For x greater than 1, third piece is defined, that is x squared plus 2. So we will put x as 1, square plus 1, the value that we are getting is 3. From left hand side, you are getting a limit that is equal to 2. From right hand side, you are getting a limit that is equal to 3. Are they equal? Of course they are not equal. Since they are not equal, we say that limit does not exist. The second condition fails. So it means the function is not continuous at x equal to 1. Now you can check it in graph too. For this is a linear part and this is a constant part. They're merged together. They're continuous. But when x is equal to 1, it is discontinuous. They're not merged together because we get different limit values. So this is discontinuous or here. So this is how we can find if a function is being continuous or discontinuous. Let's move ahead. Determine whether I will be doing it quickly. First, we have to check if f of a is defined. This is a piecewise function. Okay. This is a polynomial function. It is continuous. This is a constant function. This is continuous at every point in its domain. And this is a linear function. It is continuous. Linear, constant, and this is polynomial. We have to check continuity. Individually, they are continuous function, but we have to check continuity at x equal to 2. First, we will check if the function is defined for f of 2. Yes, the function is defined for f of 2. We will take second piece. The output that we're getting is 5. First condition is met. The second condition is that we had to find the limit x approaching to 2 from negative side. For left hand side, we will take values that are lesser than 2. That is x squared. If we put x as 2, we will get 2 squared, that is 4. So left hand limit is 4. If you want to find limit x approaching to 2 from positive side, from x approach 2 from positive side, that means we will take values, we will take function for x greater than 2, that is this function, that is negative x plus 6. So put x as 2, the output that we are getting is 4. That means left hand limit or right hand limit, they are both equal. So left hand limit and right hand limit are equal. We say that limit x approaching to 2 from left hand side, that is x squared, for this function is equal to limit x approaching 2 from positive side of x. It means left hand limit and right hand limit are equal. third condition is if the function value at 2 at x equal to 2 and the limit value when we are approaching x, when we are approaching 2, they are not equal. Here we are getting 5 as value, here we are getting 4 as value. Since they are not equal, we say that third condition is not met. This function is not continuous. You can check even in graph. Here the function is not continuous because a function is defined for f of 2. Okay, it has a limit, left hand limit and right hand limit. Left hand limit and right hand limit, they are equal, but the problem is that the value that you get from limit and the value that you get from function, they are not equal, so this function is discontinuous function. Now the last part is that this is a piecewise function, so we have to check continuity at x equal to -2. We know that if I talk about each piece individually, for the first piece, it is a linear function. We know that linear function is continuous at every point in its domain. And the second piece is constant function. And constant function 2 is continuous at every point in its domain. But we have to check, we have to find if each piece, okay, when combined together as a function, if it is continuous at x equal to -2. First we will check if the function is defined for -2. For -2, we know that we will have to take this piece because this piece is defined for x greater than equal to -2. Okay, for -2, we are getting a value that is -3. Okay, that means this is defined, the function is defined for f -2. First condition is met. Now we will check for the limit. If limit, we will check for the limit. First we will find the limit when x is approaching to -2 from left side, and when x is approaching to -2 from positive side. For x lesser than -2, we will take this piece, that is x minus 1. So if we evaluate the limit for here, we will put x as -2. So its limit will be -3. We will have to check the limit when x is approaching to -2 from positive side. That is, it is greater than -2. We know that for this, we will have to take this piece, that is -3. Since this is a constant function, doesn't matter where you want to approach, its limit value will be always equal to that of a constant number, that is -3. So this is a left right hand limit, this is a left hand limit. If they are equal, yes, they are equal. It means function has a limit value. Function has a limit value, that is limit x approaching to -2. Okay, it has a value that is equal to, for this function, that is equal to -3. Now we will have to check if the limiting value, that is this, and the functional value, they are equal. Of course they are equal. Since they are equal, we say that function is continuous at x equal to -3. Since all three conditions are met, we say that function is continuous at -3. If you have any kind of doubt in this topic, you can let me know. Thank you for watching this.